One, now we are going to start our new unit with new chapter, that is simple stresses and strains. In introductory lecture, we have understand that we have two types of body. First one is rigid body and second one is deformable body. Now this is a part of that deformable body. So what do you mean by deformable? Deformable means whenever we are going to apply force on a body, that body will change its shape and size due to external force. That's called as a deformable body. So whenever any body will be deformed due to force, there are certain chances of produces stresses and strains in that body. So first of all, we are going to understand about the stress and strain and regarding some terminology. So first of all, we are going to understand direct means simple stress and strains. As discussed earlier, simple and direct stresses are developed due to axial force, and the failure is either due to axial tension or else axial compression. Means a force is applying along its major axis, that is called axial force. Now we will study about the deformations and stresses due to axial force in different structures in details. The topics covered over here, that is stress, strain, elasticity and Hooke's law. We know that what is elasticity, and you all of have understand that elasticity in the physics. Then deformations and stresses in statically determinate structures, deformation and stresses in statically indeterminate structures, deformation and stresses in composite structure. So first of all, we have to clarify that what is determinate structure, what is indeterminate structure. Determinate structure means those structures who solved by our equilibrium conditions, that is sigma h0, sigma v0 and sigma m0. Means summation of all the horizontal forces 0, summation of vertical forces 0 and summation of all the moments 0. That is called determinate structure. But what is indeterminate structure? That structures are can't solved by these three equilibrium conditions. So stress, strain and elasticity are defined like, first of all, we are going to understand elasticity. It is the property of a body to regain its original position after the removal of external forces. If the body is elastic, it will be deformed on application of external force, but as soon as the force removed, it come back to its original shape and size. Based on the elasticity and the deformation, material are classified as the follows: elastic material, elastoplastic material, plastic material, ductile material, and brittle material. Elastic material means after removal of forces, it will be come back to its original position. But in elastoplastic, it cannot be come back to its original position. Plastic material. If a material does not regain its original shape and size at all or remains the deformed even after the removal of forces. Now ductile material. In technical world, the material undergoes the large deformation before failure. When tensile force is applied, it is called ductile material. Means whenever we are going to apply force on any body, we know that it must be fail. But before failure, that can take maximum amount of forces. That is called ductile material. Now, brittle material. If a material does not undergo any deformation on application of force and fail due to rupture, it called brittle material. Now, the most important thing, that is stress. So, we all aware about the word stress. Means let's start. What is stress? On a body, when external force is applied, it undergoes some deformation and internal resisting force are set up. This resistance force per unit cross-sectional area is called stress. Means whenever we are going to elongate any body with external tensile force, then it will be deformed. But the particles of that body must be resist that external force per cross-sectional area. That is called stress. Means stress is equal to force upon unit area. So, the indication of this stress with the help of sigma, and that sigma is equal to force upon area. Normally, stress is expressed with the unit Newton per mm square or Newton per meter square, but generally we are using Newton per mm square. Now, basically stresses have two types: normal stress and tangential stress. However, there are 5 kinds of stresses generally acted on a body, that is tensile stress, compressive stress, shear stress, bending stress, and shear stress due to twisting, that is called torsion. Now, strain. What it means? Deformation per unit dimension is called strain. So, strain is equal to change in length with respect to original length, that is called strain. The notation of this strain is equal to epsilon is equal to delta L upon L. And what is elastic limit? On a body, when external force is applied, it undergoes deformations and removal of external force, body returns to its original shape. But for a given section, there are limiting value of the force up to the when within which the deformation entirely disappear on the removal of force. The value of stress corresponding to This limiting force is called elastic limit. After this limit, it will be deform or it will be create small crack. Now, the most important thing, that is Hooke's law. Within the elastic limit, the stresses is proportional to strain. Means up to the elastic limit, stress and strains are equally proportional to each other. So we can say that stresses are equally proportional to the strain. So sigma is equal to E into epsilon, where E is modulus of elasticity. Now we have different values of modulus of elasticity, and that derived previously for a different materials. So from this equation we can derive that modulus of elasticity, or else Young's modulus, is equal to sigma upon epsilon, right? So unit of this E is equal to Newton per mm square. Now we have value of that sigma is equal to P upon A and strain is equal to delta L upon L. So E is equal to P upon A and L upon delta L. So in this case we have elasticity for the material, we have external force P, we have cross sectional area of that material, and we have original length of that material. So we are going to consider delta L as a master. So we will get the equation of delta L is equal to PL upon A. So from this equation we can calculate the elongation of that particular body with some area and with some tensile force. We can calculate the elongation. This delta L is also known as deformation and change in length, or else deformation. Clear? Good. Now, what is axial load and what is transverse load? When the element having the force applied to the along with that major axis, that is called axial load. Means when a load is applied along the axis of the member is called axial load. It may be tensile or compressive. Now transverse load, it is perpendicular to the axis of that element. When load is applied into the direction perpendicular to the axis of member is called transverse load. Now the most important thing, that is prismatic and non-prismatic bars. So what is prismatic bar? A bar having a constant cross sectional through its length is called prismatic bar. Means throughout the length its cross sectional dimension are same. But what is non-prismatic? Throughout the length its cross sectional dimensions are not equal. It reduced from here to here, or else increase from here to here, or else the diameter are changed in some middle portion of that element. Now composite and compound bar. What it means? We know that composite section, that is whenever we are considered the cross section of the element, the cross section of the bar made up of two or more different materials is called composite bar. The bar may be prismatic or else non-prismatic. Now what is compound bar? When a bar is made up of two or more material along the length, the bar, however, any cross section of the made up of only one material is called compound bar. Means different materials are joined together from its joint. Clear? Now, deformation and stresses in statically determinate structure. The deformation of body due to self-weight. Consider a bar AB as shown in the figure hanging freely undergo its own weight. L is equal to length of the bar, A is equal to cross-sectional, E is the modulus of elasticity, and W is the weight of that particular section. Now, consider a small element of dx, that bar, the distance x from B, something like this. It will be hang something from the ceiling, and the delta L, its weight and its length. So, after they put in the value, we will get delta L is equal to WL upon 2AV. We just have to remember these equations for the case. Now, the most important thing, we just understand that delta L is equal to PL upon AE, that is particular for the prismatic section. But whenever we have this kind of non-prismatic section, then the deformation means delta L is not solved by the direct equation PL upon AE. For that, we must have to derive the equation for the non-prismatic section, and that non-prismatic section having circular bar. So, equation is equal to 4 PL upon pi E d1 d2. In that case, d1 and d2 are the different diameters of the end of that section. Same way, for the trapezoidal bar having rectangle section, in that case, the equation for the delta L, and that equation is PL upon ET A minus B log A upon B. From this equation, we can calculate the deformation delta L for the non-prismatic section having rectangular shape. Now, the most important thing, that is principle of superposition. What it means? When a body is subjected to number of forces acting on its outer edge as well as some other section along the length of the body, the total deformation of the body will be equal to the algebraic sum of the deformation of individual section. This is true within its elastic limit, and this principle is called as superposition. Means this is a compound section having forces on the ends as well as intermediate section. So, due to this force, the particular first part is elongate, that is delta L1. Also, second part is elongate, that is delta L2, and third part is also elongate, that is delta L3. Sometimes first part is in tension, second part is in compression, then the delta L must be minus for the compression part. So, the total delta L is equal to delta L1 plus delta L2 plus delta L3 for the tension. Whenever all the compression, then minus delta L1, minus delta L2 and minus delta L3. So, in that case, delta L is equal to P1 L1 upon A1 E1 plus P2 L2 upon A2 E2 plus P3 L3 upon A3 E3. So, for that we must have all this P for all three parts, L for all three parts, E for all three parts and A for all three parts. So, we can calculate the total deformation of the section of compound bar with the help of principle of superposition. Another most important thing, that is deformation and stresses in composite structure. So, here it is the composite section. So, whenever we are going to apply the force on this particular section, means it will be elongate parallel to each other. Means both the part, both the material are elongate. When we are going to apply compressive force, then both the material are compressed. So the deformation of both material are same. So we can just say that epsilon 1 is equal to epsilon 2. Means epsilon 1 means for the material 1 and epsilon 2 for the material 2. And we know that the equation of epsilon is equal to sigma upon E. So here sigma 1 upon E1 is equal to sigma 2 upon E2. So we will get sigma 1 is equal to E1 upon E2 into sigma 2. And that E1 upon E2 is known as modular ratio. Means the ratio of modulus of elasticity, that is known as modular ratio. Now whenever we are going to apply the force, it will be transfer in material 1 and material 2. So P is equal to P1 plus P2, and we know that sigma is equal to P upon A. So P is equal to sigma into A. So here P is equal to sigma 1 A1 plus sigma 2 A2. So from these two equations, we can calculate the stresses produced in these two material. Clear? Good, fine. So thank you very much. This is the theory part of the simple stress and strain. In this case, we must have to memorize all the equations that we have understand. Which are the equation is most for us? Sigma is equal to P upon A. Epsilon is equal to delta L upon L. Modulus of elasticity is equal to sigma upon epsilon. Right? These are the most important equation for us. So thank you very much.